Hello guys, welcome to our project. We'll defend our project. So my name is Mahmoud, his name is Russell, and the person who stayed in the right, his name is Marjan.
So we are just finished our project and are ready to explain you all the details about project.
And subscribe to the channel and leave your comments. My advice to you is to prepare mug of tea and enjoy the video.
Let's go.
Hello everyone. This project intends to provide a quick summary of changes in food supply in 4 cities in Kazakhstan and to investigate the price variation of basic goods like milk and potato between various areas of Kazakhstan. The project consists of 3 main parts: data overview, linear regression, KAN, and CVM, and each of us will give an analysis to each of them. We are sending a CSV file that includes food kind and price information. The first thing we need to do is make sure that there are no empty entries, that all values are measured in the same unit. Well, there are several well-known algorithms for visualization. This part will be about the implementation of scatter plot, bar plot, histogram, and a pie chart. Well, let's use the Seaborn scatter plot tool to visualize our dataset. We will only use the price and the product function inputs when categorizing the data points into categories. In this case, this is regions. According to the graph, over the course of 15 years, the cost of the same products around the cities has steadily increased. The next step is to visualize each city in more detail. Well, the bar plot method is then used to create the graph. A bar plot gives some insight into the worth of the pricing of each particular type of goods by representing an estimate of central tendency for a numeric variable with the height of each rectangle. The bar graph shows that the prices into 2 regions of Kazakhstan are comparable to one another. Almaty has higher milk prices than Nur-Sultan, which has noticeable higher meat prices. And between 15 years, a continuation of this trend has steadily, and the cost of beef generally ranges between the cities at 1,100 tenge on average. Let's talk about histogram. And the histogram in a project is used to represent data presented as groups. It's an accurate method of graphical representation of the distribution of numerical data. This is type of histogram where the x-axis represents price and the y-axis gives frequency of information. A pie chart is a circular statistical graph that can only display one series of data. The area of the chart is the total percentage of the data we have given. The area of the sectors of the pie chart is the percentage of the price for each product over 15 years. The pieces of the pie are colored wedges. The area of the wedge is determined by the length of the arc of the wedge. The area of our wedge represents the relative percentage of this part in relation to all product prices.
Linear regression. Let's look at linear regression for this data. But before we begin, I think it's best to explain what linear regression is in one sentence. So, linear regression estimates the coefficients of linear equation containing one or more independent variables to best predict the value of the dependent variable. Our mission is to make the most accurate prediction using linear regression. In our example, let's consider the price of meat beef in the whole region that we have, like Astana, Almaty, Aktau, Kostanay, and over the time, more precisely from 2005 to 2020. How it varies, yeah. Many people say that the food has become very expensive, especially meat. Uh, by by drawing a scatter plot, we can understand that obviously and visually the price has gone up, and the people face like that. But how much has risen proportionally? And as I said earlier, for an accurate forecast, we need to the help of linear regression. Now, in order to find the regression line, let's prepare the table correctly. Since we have the date type saved as an object in our table, we first convert the date type to date time using to date time method. Also, the price to float. Next, to work with dates, we use the date time cardinal, which returns the proleptic serial number of the dates according to the Gregorian calendar, where January 1st of year 1 has the serial number 1. Now that all the data is ready, using the ready-made method, regplot, we can figure out the best option of regression lines. So since the data is current for 2020, let's assume that 2022, this table is supposedly from the future. With the help of that coefficient and the intercept, we have already calculated. We can predict the price in 2 years, or rather the price today, and compare it with the present average price of beef across Kazakhstan. Since we have in the table a serial number of dates according to the Gregorian calendar, as I said before, we take the last data, that data, and add it 2 years in days, and that is come out. So further putting the formula, we find 2048 tenge. That is according to the prediction with the linear regression. At this time, price of meat should be 2048 tenge, or should be in this interval. Now, according to site, the average retail price of Kazakhstan's favorite beef in February 2022 was 2082 tenge per kilogram. That is our prediction coincides. Congratulations.
So let me start with my part, which was the KN and SVM. So let's start. So as you know, our train algorithms don't work without the data, and we should give the proper data. So we for this part we need the target one, and the category will be best fit for our purpose. So and also we need the features, but the features more problematic one. So I have the best feature graphs. Uh, these graphs illustrate how the columns is work each other. For instance, latitude, longitude, and price and USD price gives the properly. So as you can see, these graphs much more fitter for our classification one. And here we have the categories. You can pause if you want. Here I illustrate you our data much more larger, and we can briefly see here that blue one and green one couldn't separate, and yellow and red one is overlapped for this in this region. So we can decide here to took yellow and green one, which was cereal and oil. So this was our final data, which we decided. So let me introduce you about the Keenan and SVM algorithms. Keenan is the calls as k nearest neighbors. For instance, for this example, if the three neighbors for unknown data, we have one star and two triangles, and this data will be triangles since two triangles versus one star. When it comes to seven neighbors, we have the three triangles versus two stars. So this data will be stars, and based of the k, we decide our data was a triangle or star in our case. When it comes to support vector machine SVM, we draw the line and decide in which side replace the data. It would be the class. For instance, if they replace it here, it would be red square, and this one green circle. So how you think which one is the much more fit our data? You can pause and think about it. So let me show you answer. So based of the accuracy is the much decision factor here is the accuracy, and here Keenan gives us 97% of accuracy. When it comes to SVM, give us 67%. And here the example graphs illustrated how SVM works. Is divided our data into two parts. So for our data, much more fitter and suitable, which was the Keenan algorithms.